In this video, I'll be giving a brief recap of things that we've learned about the heating curve as shown in the diagram here. So as a reminder, the heating curve is a graph that shows temperature along the y-axis and energy along the x-axis here. So as we move to the right, we are increasing energy, and as we move up, we are increasing temperature. As we can see from what's shown here, we have different types of regions in the heating curve. Some of them are slanted and some of them are flat. During a slanted region, as we move to the right, we are also moving up, and this means that as the energy is being added, we are also increasing temperature. This applies to the three slanted regions that we have as part of this curve. The flat regions do something different. In those, we are seeing that as we add energy, so as we move to the right, the temperature stays the same. So if we're adding energy and the temperature isn't changing, that energy must go towards something. So these are the regions that correspond to changes of state. As we add energy in this case, we are changing to a higher energy state. And so for the lower region down here, the one at lower temperature, we are going through the melting process, going from a solid to a liquid. And at the other one up here, we are going through a boiling process. We're going from the liquid to the gas. The temperature associated with each of these regions would be the melting point, or MP for the lower region, and then boiling point, BP, for the temperature of this higher region. So again, we have 5 major regions here. We could number them across as 1, the first slanted region, 2, the flat region after that, 3, the slanted region for another flat region, and then 5, another slanted region after that. And we can also think about these in terms of what state of matter exists during that region. We know that regions 2 and 4 are changes of state, and since the change of state that happens at the lower temperature is going to be the melting process, that means that we have a solid going to a liquid during region 2. And since region 4 is the other one at higher temperature, then that's the liquid going to the gas, the boiling case. In between here, we've changed to a solid, from a solid to a liquid, and then we're changing to a liquid to a gas. So this helps us to see that region 3 would correspond to when the substance is just a liquid. We saw this as part of our experiment that we did with the water when we took our ice sample and put it on the hot plate until it began to boil. And we saw that during that temperature rising region that we actually recorded, that the sample was purely liquid there. We also extended beyond this to say that after we finish the boiling process, if we continue to add energy, then that would mean that we are still going to have the gas, but it's going to be heating that gas hotter. So region 5 corresponds to the gas state of matter. And on the other hand, if we were to take the ice that we had at the beginning and continue to take energy away from it, continue to cool it further, then it would stay ice, but it would get to colder and colder temperatures, corresponding to region 1 being our solid region. So this summarizes the different regions of the heating curve and what each one represents. We will be using these heating curves to solve some of the quantitative problems in the next video.